All right, in this video, we're going to take a look at some examples of using our angle sum and difference identities. So we have alpha is a quadrant 2 angle with the sine of alpha is 5/13, and beta is a quadrant 3 angle with the tangent of beta equal to 2, or 2 over 1. So we're going to find each of the following. So we'll be finding a lot of angle sum and difference identities in this example. Now, the good news is each one of these examples in this video are going to use the same information we have here. So once we figure out what the sine, cosine, and tangent of angle alpha and angle beta are, we can just reuse those ratios and plug them in. So we'll see that in here as well as some shortcuts. So first thing we're going to do with this problem is we're going to find all the x, y, and r for alpha, and then do the same with beta. So we know the sine, it's in quadrant 2, so our x's are negative. We're going to need Pythagorean theorem to get our x coordinate, which is -12. So we have x is -12, y is 5, and r is 13 for alpha. And then for beta is in quadrant 3, the tangent is 2. Tangent is y over x, and because it's in quadrant 3, both y and x are negative. So y is -2, x is -1. We're going to need the value of r, so we're going to have to use Pythagorean theorem, and we get the square root of 5. So summarizing what we're going to be using for x, y, and r in this problem, for alpha, x is -12, y is 5, and r is 13. And for beta, x is -1, y is -2, and r is square root of 5. So now we can use these values and substitute them in for the sine, cosine, and tangents of alpha and beta respectively. All right, so again, just making a note of everything up here so I don't have to go back. Sine of alpha minus beta is the sine of alpha times the cosine of beta minus the sine of beta times the cosine of alpha. In terms of our ratios, the sine of alpha is 5/13. We were told that in the beginning. Cosine of beta is x over r, which is -1 over square root of 5. We'll rationalize that in a second. Minus sine of beta is -2 over the square root of 5. So -2 for y over the square root of 5 for r. And the cosine of alpha is -12/13. So -1 over the square root of 5 and -2 over the square root of 5 rationalize to negative square root of 5 over 5 and -2 square root of 5 over 5 respectively. So now we can just use these rationalized results for sine beta and cosine beta. So multiplying our expressions, we get -5 square root of 5 over 65, and then we get minus -2 radical 5 times -12 is 24 radical 5 over 65. So -5 square root of 5 over 65 minus 24 square root of 5 over 65 gives us our final answer of -29 square root of 5 over 65. Part B, sine of alpha plus beta. Well, with the difference of the two formulas being the minus versus plus in the middle, it doesn't really make much sense for us to redo everything when the only thing that's really going to change is that plus sign in the second to last step. So instead of subtracting our two ratios, we're just going to add them, and we get 19 square root of 5 over 65. So again, pays to think smart. Part C, cosine alpha minus beta is, again, cosine alpha, cosine beta, plus sine alpha, sine beta. We're going to use the rationalized ratios for sine and cosine of beta. So when we multiply through, we get +12 square root of 5 over 65, and then plus -10 square root of 5 over 65. And these come out to equal 2 square root of 5 over 65. Part D, cosine alpha plus beta. Well, again, we're just going to switch the plus that's in the middle to a minus. So now we have 12 square root of 65 over 65 minus a -10 square root of 5 over 65. And that becomes 22 square root of 5 over 65. Part E, tangent of alpha minus beta. So we have tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta. Well, substituting in our results here, we have -5/12 for tangent of alpha, and we have 2 for the tangent of beta. So when we simplify the numerator and denominator, we get -29/12 for the numerator and 2/12 for the denominator, and we can clear out that complex fraction by multiplying both numerator and denominator by 12, and we get -29/2. As an alternative to that, we could also, since we already figured out the sine of alpha minus beta and the cosine of alpha minus beta in previous problems, we can just substitute those values in, and now we can multiply by 65, and we get negative 29 square root of 5 over 2 square root of 5. The square root of 5 over square root of 5, that's going to divide out to 1, and we get negative 29 halves. So we get the same answer, but here we can just use, since we already figured out the sine and cosine differences, we can just use those results to make shorter work of our problem. So that about does it for this video. Thanks for watching. I'll see you next time.